Okay, so now after we installed the module to the machine, the flow should come when you turn it on. We should get the flow comes downward into the flat plate. And for us, we're trying to survey the flat plate boundary layer thickness at different location of X. X is measured from the leading edge, which you can see it right now at 140 millimeter, all the way to the pitted tube where you're doing the measurements, which is always set to be at 0. The plate itself is movable, so you can actually move it up and down from these small screws that you have here. You can untie them, put them up or put it down to get the new location on X direction. So currently it's at 140 millimeter. Okay, so you're scanning the velocity by going in the horizontal direction, which actually in that case we refer to it as Y direction. So you're moving the pitted tube. That's not pitted static tube, it only take one measurements. So you can see here, you can move the pitted tube by moving the micrometer here. The sensitivity of the micrometer is very small in a way that you can get to 1/100 of a millimeter, which is correspond to 10 micrometers distances. So we started from a location that is exactly at 0. And the problem here, you're never gonna get to the 0. The reason that you have the diameter of the pitted tube itself. The pitted tube has a very small, tiny diameter there that is actually equal to 0.35 millimeter. So your first position, whether we like it or not, is going to measure the velocity at 0.35. You cannot go all the way to 0. It needs initial calibration by setting it up exactly at the surface and put the value of the micrometer here to 35. So let's discuss a little bit how you operate this micrometer. So the micrometer, when you go all the way to 0, and I'm trying to zoom in, and I hope it's clear enough. So this is where you have 0 on the right and 0 on the left. That correspond to exactly a 0 value there, okay? You have a very tiny dash in the background pointing downward. It's another 0 downward, if can be seen. Let me try to get this in focus. So you have a 0 in the background. You see only half of it. We'll see it as we move away from the surface. So your first point should be exactly at 35 here. So 35 on the right, 0 on the left, and you only start to see the full 0 on the bottom right there. This should be your first position, where the pitted tube just touching the surface. Okay, so you keep playing with this and tie this at this position, and that will be your first position to start. Okay, in the lecture you're going to be given the values where you do the measurements, but we normally try to go every 25 or 0.25 millimeter. And here in that case, if I move to 0 again, that will make it exactly to 0.5 millimeter. So we moved from 0.35 millimeter to 0.50 millimeter, which by 0.15. So we start from this point to move every 0.25. So we want to go to 75 or 0.75 by moving only to 25 here. So you can see a very small dash there. I know it's a little difficult. That actually corresponded to 1/2 millimeter already there, plus a 25, so it give you a 0.75. If I go further down and get a random value here to see a reading, you can see right now I have 2 dashes on the bottom and a 0 at the same time on the main dial. That corresponded to 2 millimeter. Let me go further a little bit. So 2 dashes at the bottom, each one correspond to 1 millimeter, and a 0, then we're still at exactly 2 millimeter. So if I move, let's say, to another 25 on this side, So that should correspond now to 2.25. Okay. So you move every 0.25. As you go farther away, above 2 millimeter, you can start to move around 0.5 millimeter at the time, because the velocity starts to move a lot slower. Very close to the surface, you have no slip condition, so you're going very big values as you move very small increments. As you go farther away, the changes will take a longer distance to happen. So you don't have to really move with the same distances. So you're repeating this experiment at 0 location, which is, we know that if you bring the plate down here all the way to 0, and then you move to, let's say, 2 centimeters, the plate, then your measurements at 2 centimeters, which correspond to 20 millimeter here, 40, 60. As at each location, you want to move on the Y direction, which is right now in the horizontal direction, with the micrometer to take enough measurements. And that enough measurements goes on average of around 10 points. In some cases can be 12, because you keep going further outside from the plate, outward of the plate, and you still see changes in the velocity, so you keep moving until you get 3 points that having the same value of pressure measurements. This pitted tube is connected to the manometer to the right-hand side here, where you're actually reading the values of the pitted tube itself. Okay, so now we see every 1 or 2 centimeter, we move the plate and we repeat around 10 different measurements as we go horizontally with the micrometer. You could end up with hundreds of different measurements. We do this for a smooth surface, which is installed right now, and for 2 different speeds, so we can see the effect of the speed on the boundary layer flow. And we flip the plate and we started to do the measurements on the rough surface, where you see the sandpaper installed right there. We're doing the same process over and over. You need to collect enough data to get the profile of the velocity at different locations in Y, until you end with the thickness of the boundary layer. To measure the boundary layer thickness, that's a different topic. You're gonna need the instructor to go over it to give you exactly how you use the data to come up with the boundary layer thickness. But in terms of operation here, you operate the machine the same way that we discussed it earlier. You turn it on, you go with the dial to the value that is given to you. Let's say it's around, 40% or 60%. Right now it's exactly at 40%. Okay, and at that time you scan the Y, starting from the smallest value all the way to the highest value, which could be around between 1 millimeter to 5 or 6 millimeters. This is in this direction, and we call it the Y direction, which is horizontal in that case. And then you move the whole plate to take another measurement. So as I mentioned before, this is at 140 millimeter. I'm gonna change the location and show you right now at different locations. So if I go to 20 millimeters, that will be the measurements. As we agreed, the pitted tube doesn't move, only the plate moves. So if you see now, we're located exactly at 20 millimeter. So you keep moving the plate upward, which means the distance X, which in the direction of the flow will get bigger, and you can repeat the measurements to end up with the flow measurements. Okay, with the instruction that are given in the lecture, you should be able to use this information to understand how the experiment can be conducted in that case.